Welcome. Today we will be discussing how to graph a linear equation. Now, a linear equation can be written in several different ways, but typically the form we want to have a linear equation in order to graph it is in the form of slope-intercept, which is y equals mx plus b. The reason being, the equation of slope-intercept form already sets up the necessary variables needed to graph the whole entire equation without really much math involved. We know that the b value here on the end, this is known as our y-intercept intersection point. So that tells me where on this axis my line will intersect. And my m value here, we know as the slope. And this is my rate of change, how many values I'll be going up or over from my y-intercept intersection point to my next point. So what I would like to do is get both of these equations that I have over here into slope-intercept form so that I can graph them. In this situation, we're going to start with this first equation, y equals -1/2 x plus 2. Okay, and in this situation, this equation is actually already in the necessary form in order to graph it. We have our y-intercept value right here, and we have our slope attached to our x right here. So I'll be using both of those points to graph my line. So we start with our equation, y equals -1/2 x plus 2, and we say our b, or our y-intercept value, is at the point of plus 2. So I go from 0, 0 in the middle of my graph, and I go up 2 on my y-intercept, my vertical axis. Since it's a positive number, I go up 1, 2 terms, and I stop there, plot a point. Now from there, I will be using my slope of -1/2. From that point I plotted of 2, I'm going to be going down 1, since 1 is a negative number, and I'm going to be not stopping there, but now I have to move, because recall our slope is y over x. It's my y movements over my x movements. So it tells me how many times I move up or down, then how many times I have to move left and right. Then I plot my point. So again, my y value was -1, so I'm moving down a point, but I'm not finished. I have to move to the right twice for my x value. Even though our value was -1/2, only one of our terms here can be negative, only the 1 or the 2. Both of them cannot be negative. So in this case, since my 1 value was negative, my 2 is positive, so I'm moving to the right twice. And I can plot this again if I wanted to. I can go down 1 more from my point here and go to the right 2 more and plot my next point if I would like. And then I can draw my line through my points. And I've drawn or graphed my linear equation. Now the second problem here, we have 2x plus 3y equals -3. This is not in the form of slope-intercept, so I need to get it into slope-intercept form. So what I'm going to do is I need to isolate my variable y, because recognize that slope-intercept form says y equals mx plus b, so y is isolated by itself. So let's isolate y. I'm going to do that by using the inverse operation over here and subtracting 2x from both sides. That'll leave me with 3y equals -2x minus 3. I have one last step. I need to isolate y. Divide by 3 using the inverse operation once again. Isolate y, and I'm left with y equals -2/3x minus 1, because 3 obviously goes into -3, -1 time. Perfect. I have my equation in slope-intercept form. Start with our value on the end here, what's known as our y-intercept, our b value. It's telling me it's -1, so I start at -1 on my vertical axis. From there, I use my slope, -2/3, so that tells me I need to go down twice, 1, 2, and to the right 1, 2, 3 times. I can continue to do that. My graph obviously isn't big enough to cover that, but we can also go the opposite direction. Since recall I said if one of the terms is negative, the other one has to be positive. So let's say the numerator, the positive, is the positive term, the 2. So we'll go up 2. And this time make the x value the negative. So we'll go left 3, 1, 2, 3, and we can still continue to plot our points and make our line. And from there, we've graphed our linear equation.